this lab I'm going to show you voltage drops across the series circuit. So to do that, I have a spark view, I have a Pascal pole, I have 3 batteries, they are connected, I have some alligator clips, and most importantly I have 2 resistors. This one is 100 ohms and this one is 10 ohms. First I'm going to connect the Pascal pole. I'm going to attach the Pascal pole with this spark view, and that will give us this. Now the next thing we're going to do, we're going to of course press build, and then we're going to press current 1 2 3. We want to have current and voltage side by side, and then voltage, and then 1 2 3. Okay, now OK. If you press OK, then you have voltage and current. Okay, that's very nice. Now if you have this, so this is the ammeter, this will measure the current. When you measure the current, make sure you attach the resistor to the circuit, otherwise you gonna have a short circuit. So you can, one way you can do that, you can make a little opening over here and insert the wire over here, and that will make a connection. If I plug this in over here, then there would be a short circuit. You hear the sound? Because there is no resistance. So I have to make sure that I use resistance. Now it is a circuit with resistance, now there will be no short circuit. Okay. Alright, so now let's see how much current flowing through this circuit. As you see that 0.04, so I'm going to write 0.04 current flowing this circuit. Now the main objective of this lab is to show the voltage drops. Let's first measure the total voltage. To draw the total to read the total voltage, measure the total voltage, I'm going to use the voltmeter. This 2 wire will measure the voltage. So I'm going to place it in one terminal and place it at the other terminal, so it can measure the voltage. Now let's see how much voltage we have. 4.35. So that how much voltage we have, 4.35 voltage. So again, the main idea is not to find the total voltage, but to find the voltage drops across the resistor. To do that, I'm going to take this off. I'm going to come over here, and this is my first resistor, and that has only 10 ohms. I'm going to put it over here. No, this is the wrong one. This is the wrong one. I'm going to take this off. I'm going to put it over here, and I'm going to put this over here, and that gives me voltage across the 10 ohm resistor, and that is how much? 0.38. Good. Write it down. Now I'm going to take this off because this is the voltmeter, and I'm going to put that across the 100 ohms resistor, and I'm going to see the voltage 3.92. So I'm going to write that down, 3.92. and the current of course also 0.04. The current never changes in a series circuit. The current across the series circuit stays the same, which is 0.04 amps. So now I'm going to take you to the smart board and help you understand these voltage drops. This is a positive terminal, this is a negative terminal, this is 4.34 volt and 0.04, because current is the same across the circuit of a series circuit, and that's what we saw. And this one received 4.34 volt. How much this one consumes? This one consumes 10 times 0.04 is 0.4 volt. This one consumes 0.4 volt, and that's what we call voltage drop. Voltage drops. This one releases how much? About 4, right? About 4, because this one consumes about 0.4 volt, so this one release about 4 volt. And this one consume how much? Well, 4 voltage, and that's what we call voltage drops. Voltage drops. So voltage drops is about 4 volt, and voltage drops over here about 0.4 volt. Okay. So how much this one release? 0 volt. So again, 4.34 voltage goes there. Bulb number 1. Bulb number 1 or resistor number 1 consumes 0.4 volt. We call it voltage drops. After consuming 0.4, it releases a remaining, and that would be 4.34 minus 0.4, which is approximately 4. Okay. This one receives 4 and it consumes 4. Why? Because VIR, voltage is resistance times current. So 100 times 0.04 is 4. So this one consumes whatever it receives. And this one releases 0 voltage. So this is called voltage drops across the circuit. However, you did not see exactly the same figure. What did you see is this 4.34. yeah, this is good. I'm going to use the different color. Let's see what color I can use. I'm going to use this color. Here you see 0.38. So here you saw 0.38, and instead of 0.4 you saw 0.38 voltage drops. Okay, and here you saw 3.92 instead of 4, 3.92, which is pretty close. It's not perfect, but pretty close. Now the equivalent resistance, if you use the Ohm's law, is going to give you the equivalence resistance. So if you write the equivalent resistance, you get the voltage divided by current. So the voltage is 4.34 and the current is 0.04, approximately 110. And guess what? 10 plus 100 is 110.